Hi there, this video is going to be about solving one-step equations. Now if you look at the equation n plus 3 equals 8, what we're going to do is picture this equation as sitting on a teeter-totter or seesaw or balance, whatever you want to call it. The equal sign is our fulcrum, and we will put the n plus 3 on the left and the 8 on the right. The thing about equations is they always have to be balanced. If you add something to one side or another of a teeter-totter, it puts it out of balance. But if you put the same thing on both sides, the teeter-totter or seesaw remains balanced. And that's how we approach equations. So if I have the equation n plus 3 equals 8, the first thing I need to do is look at my variable. That's what I'm trying to solve for. My goal is to get n equals something. Right now I've got n plus 3. So my goal is to get rid of 3. So the opposite of adding 3 would be subtracting 3. So if I look at my seesaw, here's what I'm going to do. I'm going to subtract 3 from the left. But in order to keep balance, I've got to subtract 3 on the right. Now on the left side, when I take a positive 3 and subtract 3, I get 0. And on the right side, 8 minus 3 is 5. Now because n plus 0 just equals n, what I end up with is this. I get n equals 5. That means my solution to this equation is n equals 5. All right, let's look at another one. Here's another problem. This one has subtraction. N minus 7 equals 6. So again on my teeter-totter here, I've got n minus 7 on the left and a 6 on the right. Now the opposite of subtracting 7 would be adding 7. So if I do it to the left, I must also do it on the right. That gives me the following solution. Since subtracting 7 and adding 7 gives me 0, I just have n on the left side, and then 6 plus 7 gives me 13 on the right side. So the solution to this problem is n equals 13. Okay, here are a couple problems that are very similar to the ones that we worked out, but no teeter-totters. Here's how we solve it. Same idea. If I have the problem k plus 9 equals 20, I'm going to write k plus 9, and I'm going to leave some space, and then I'm going to write equals 20, because I know that what I'm going to need to do is subtract 9 to get rid of this plus 9. So I'm going to write a minus 9 and a minus 9. The same thing gets written on both sides, because then I have k plus 0 equals 11. And we know that anything plus 0 is just that value, so I get k equals 11. Now over on this one, I would write it down, x minus 23, and I'm thinking ahead, and I know I'm going to be adding 23 to both sides, so I'm just going to leave some room. To undo minus 23, I'm going to need to add 23, and if I do it to the left, I have to do it to the right as well. So then what I end up with is x and then plus 0 equals 33. So my final answer is x equals 33. So now let's look at some one-step problems that involve multiplying and dividing. Alright, so here's our next problem. When I look at 3 times n equals 12, again, I'm trying to figure out what n is, so I have to undo what's being done to the n. Right now I have 3 times n. Well, the way that we undo multiplication is to divide. So I'm going to divide both sides by 3 and see what happens. Now, I can use this division symbol, but I would like you to get used to using another division symbol, which is a little more clear when we look at equations. Instead of using the traditional symbol for division, I would like you to use the division bar. So dividing by 3 means putting 3 underneath in both of these fractions. So divide this term by 3, divide this term by 3. So what happens when I take 3 divided by 3 is I get 1. Over here, 12 divided by 3 is 4. So here's what we get for our next part. Since 3 divided by 3 is 1, I get 1 times n equals 4. Now we know that 1 times anything is itself, so I can rewrite that to be just n equals 4. That's my solution. Alright, here's the last type of our one-step equation solving. This has a number n divided by another number. So to undo division, we multiply. So the way that I'm going to multiply is, remember that this is a fraction, so when I want to multiply by 5, I'm really multiplying by 5 over 1. And over here, I would also say 5 over 1. Now on the right side, that 1 isn't really important because I'm multiplying it times a whole number. But on the left side, what I end up with is 5 times n over 1 times 5. So what that looks like when I take 5 times n over 1 times 5 is 5n over 5. Now we know that 5 divided by 5 is 1, so I get 1n equals 35. Or simply n equals 35. So let's look at a couple problems without the teeter-totter. Here I have n being divided by 3. To undo division, I multiply. So I'm going to multiply both sides by 3. Now since I have a fraction on the left, I do need to think of it as a 3 over 1. 3 divided by 3 is 1, so I get 1n equals 8 times 3, which is 24. 1 times n is just n, so my answer is n equals 24. Over here on this one, I've got 8 times k equals 40. To undo multiplication, I would divide by 8. And if I do it on one side, I have to do it on the other side. 8 over 8, or 8 divided by 8, is 1, so I've got 1k equals 5. So my answer is k equals 5. There are a couple of cases that I want you to take a look at because they are done just a little differently. If I have 2/3 times x, it would be kind of messy if I divided by 2/3. It would work, but I have a complex fraction, which is kind of a mess. Same over here. If I think I'm going to divide by 3, I get a complex fraction on the right. So there's a little bit of a trick that we employ here to make it a simple one-step problem. There's another way to get this to be a 1x. And the way that I do that is, instead of dividing by 2/3, I multiply by the reciprocal of 2/3, which is 3/2. And if I do it on the left, I must do the same thing on the right. And since I'm multiplying with fractions, I'm going to put that 5 over a 1. So on the left side, I get 6 over 6 x equals 15 over 2. Now we know that 6 over 6 is 1, so my final answer is 1x equals 15/2. If you would rather write it as 7.5, you're welcome to do that, as long as it's simplified. Now over here, I'm going to do the exact same thing. It might not seem so obvious, but 3 is the same as 3 over 1. So if I pick the reciprocal, that would be 1/3. And if I do it on the left, I must do the exact same thing on the right. So on the left, I get 3 over 3, which is 1. So I end up with 1x equals 1 over 24. So my final answer would be x equals 1 over 24. So to wrap this up, it's important that you look at every equation as sitting on a teeter-totter with the equal sign being the fulcrum. You must keep the equation balanced by doing the same thing to both sides of the equation. And also remember that addition and subtraction undo each other, and multiplication and division undo each other.